This week on Quality Digest Live, we examine Henry Ford's universal code for success.
Plus, the wisdom of Taiichi Ohno and the power of learnership. That and more when we come back.
Welcome back to Quality Digest Live for May 10th, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
Yes, he is, and I'm Quality Digest publisher Mike Richmond. Okay, do you know what it takes to develop a truly world-class operation?
No, Mike, tell me.
I'm going to tell you, Dirk, right
thanks.
now. If, like so many, you're searching for the key to breakthrough improvement, our recently released book may provide the answers that you seek, and I have it actually right here. Right here, actually. The Outstanding Organization: Generate Business Results by Eliminating Chaos and Building the Foundation for Everyday Excellence is the name of the new release by Karen Martin, and it's been published by McGraw-Hill Professional. So, what does it take to build an outstanding organization? Well, first of all, as mentioned in the subtitle of the book, you need to learn to control chaos. All great organizations are consistent, and as Martin says, consistency has no greater enemy than chaos. It's up to management to impose order through 4 key behaviors: clarity, focus, discipline, and engagement. Martin's approach to ridding your organization of chaos is simple and elegant. This is not one of those books that is chock full of jargon and slogans. Instead, it offers practical examples from successful real-world organizations in diverse industries such as healthcare, auto manufacturing, insurance, and food service. These best-in-class companies applied clarity, focus, discipline, and engagement. Again, it's those big 4 things. And they reap the rewards. Making small incremental changes can yield big results in terms of business performance. And this book, again, shows you how. This book actually is a Shingo Award winner.
Oh, okay,
Dirk,
cool.
I don't know if I mentioned that, but it's Shingo Award winner for journalism, I believe. So, a complete review of the Outstanding Organization, the book, was written by our very own Laurel Tennis, and it appeared in Wednesday's issue of Quality Digest Daily. So, for more information on the book, including a link where you can place an order, just check out Laurel's article right below the video player, right down there. In fact, as always, you can find links to all the stories we're going to be covering on today's show right down there. Now, this was a Shingo Award-winning book, and a good read, a quick read, not real lengthy. A couple hundred pages, but great practical examples. And I learned a lot. I know Laurel learned a lot from the book as well.
Well, I mean, that's true of a lot of the Shingo winners, is they're really, Mark Graban's book was also on there. They're very, if they've won a Shingo Award, it really means that they, in general, tend to be practical. I mean, they're really how-to type books that really make sense in terms of the average everyday person being able to apply principles to their organization. So,
that's right. Okay, so for more on that book, check out the story link. Again, just below the player page right down there. Okay, we're going to turn now to our second news item of the day, and this is a really good one, a little different today than we normally do our news items. Dirk is going to be joined now by a couple of members of the Sustainable Manufacturing Program at Chico, the Chico State University, actually California State University Chico, which is our home university here in Chico. And we're going to find out a little bit more about an award they won at Aerodef about a month and a half ago. So take it away, Dirk and the guys.
Yeah, well, thanks, Mike. I'm here with Darren M. Otten, Assistant Professor and Coordinator of the Sustainable Manufacturing Program at California State University at Chico, and also Luke Hendricks, Chairman of the SME Student Chapter, S139, and also a Sustainable Manufacturing student at CSU Chico. Before we get to Luke's project, tell us a little bit what happened with your team down in Southern California.
Well, we're really excited, first of all, to be here today, but also to talk about our projects and our student success. We've seen a renaissance of manufacturing here in the United States continuing to grow, and our program's very reflective of that. We're starting to see lots of student growth. We're starting to see student growth from areas we traditionally haven't seen, which is female participation in this particular space. And, our program combines engineering, technology, hands-on machining, casting, plastics, all these kind of things that go into the manufacturing sector, but also plugs it in with business. Things as dry as accounting, but you need to know how to do those sort of things ultimately in these spaces. And this project really is a culmination of all those student skills across the boards that is geared towards this Bachelor's of Science in Sustainable Manufacturing. It also should be noted that Luke and his team, this is not a class credit. This is not like they're earning any class units for this. This is all a student club, Society of Manufacturing Engineers student club, and it's all on their own dedicated time.
Okay, and so what happened, Luke, is your team, I think, a dozen of you or so went down to Southern California for the Aerodef conference, right?
Yes.
And what happened when you were down there?
Well, what happens is we went down to the competition. We brought our cylinder head, all the associated documentation that we developed with the project. And what happens is we present in front of a panel of judges among other schools who are attending. There is a college division and then a two-year university division. And the judges go through. You have 10 minutes to present your project, and then they go and they present you your award.
And what award did you win?
We won the Best in Show award at the Aerodef competition, and what that is recognition of is basically recognizing that our project related and tied in to the aerospace, manufacturing, and defense show that they had there, and that it was also deemed pretty much the best project that was there. Okay,
so tell us about the project. It was a cylinder head, right? Maybe we can get a quick shot of this, Daniel. There we go. So this is there we go, a cylinder head. Tell us about the cylinder head. What's the purpose of it?
So the purpose of the cylinder head is to allow you to use lower octane fuel in the cylinder head as opposed to low-leaded, high-octane fuel.
And this is for aircraft engines, right?
This is for four-cylinder aircraft engines. These are typically going to go as a replacement to a Lycoming cylinder head that you're going to see on experimental aircraft. And we did all the design work for the manufacturing system on campus in our club. So what you see here is the finished product, but we were more involved in the manufacturing and the production system and all of the associated work along with that.
So basically a person from outside the university came to you and said, I got this idea for an engine that's going to run on unleaded fuel, lower octane. Can you guys somehow figure out a way to make this? Was that the idea?
Absolutely, that's exactly what happened.
And were you able to do this completely within the university facilities?
Yes, we did all of the design work for the casting and the tooling, and we did all that on campus. So we cast the part, we did the heat treatment on the aluminum, which is cast 356, and then we sent it out for the X-ray inspection. That was the only capability that we didn't have on campus. And then when it returned to us, we did all the machining on the cylinder heads, utilizing our Haas CNC equipment, and then we did quality inspection using our MicroView CMM. Okay,
so what makes this part of a sustainable engineering program? Why would this qualify for because it's a lower works with lower octane gas and more fuel efficient, that sort of thing, or just better for the environment? Is that why it fits in with the sustainability?
Yeah, really, you just covered all the points, those working together. And then the other one too is that in California, the regulations for gasoline and emissions for air quality, the person who designed the cylinder head, he sees in the future those restrictions becoming greater and an increase in the requirements there.
So he's kind of getting ahead of the game.
Exactly.
And I should point out, this is not for licensed aircraft, right? This is for experimental aircraft, right? So a lot of the FAA stuff doesn't really apply as it would if this was for a commercial aircraft.
Yeah, at this stage, that's just because of what's feasible right now. If his ideal situation is bringing this forward and putting it through FAA certification.
And this is the 14th time a team from your program has won down at the Aerodef?
Chico State and the predecessors to the Sustainable Manufacturing Program have always had a very, very good track record down at Aerodef and the predecessor competition at West Tech. And this four-year division that Luke's been talking about, I believe it is the 14th time that they've taken the top honors at that particular event.
Wow, that's terrific. So now you said one thing that's interesting is that your program has seen an increase in the number of female students, right?
It has.
In an engineering program.
Yeah, and we've seen an increase across the board in students generally who are interested in manufacturing, and then there's a lot of reasons that I think we can attribute that. Part of the challenge, of course, has been, I think, and the big takeaway, which is exciting for the future of manufacturing, especially in the United States, is that we have students today who are interested in tangible results of their daily work.
Okay. And Luke, you're graduating this year?
Yes.
Right? And are you going to be working within the same field?
I'll be taking a position that's more directly related to CNC manufacturing.
Okay.
And also some production management.
And what are you taking away from this program yourself personally? What does it mean to you?
It means a lot. I feel coming out of this program, based on the classwork and the academic strengths, and also the things that I've learned through my extracurricular activities, which is what we're talking about today, I feel very well prepared going out into the workforce, and it's something that I am very much looking forward to.
All right, awesome. Well, Darren, thank you for joining us, and Luke, congratulations and your team on a fantastic project and winning it down at Aerodef. That's pretty cool. All right, Mike, back to you.
Thank you, Dirk, and thank you, Darren Otten and Luke Hendricks of CSU Chico, California State University Chico, the Wildcats, our local university right here in Chico. Great work done by those guys, and we're really happy to be able to bring that to you. Dirk, you know, I think that was a really good segment because it shows kind of the real practical effect of STEM education when it's done properly and really how it impacts industry.
Well, I'm intrigued. I don't think Darren gave the number, but I believe he said 15% of their students are in this program are female.
Yeah.
And for an engineering program, I'm not sure, but I think that's probably a fairly impressive number for an engineering program.
Probably fairly high, yeah.
You know, when you consider that the university itself, this is your typical university, it's roughly 50-50, male and female. To have 15% into really a hard science program is pretty darn cool.
Pretty darn impressive.
Congratulations on that, guys.
Thank you guys for joining us again. Always good to work with a local university.
Yep.
Do some coverage like that. Okay. Well, let's turn now, Dirk, if we could, to our feature articles, and we had a couple of really good features this week. We're gonna kind of get to them. We're gonna talk a little bit about some of these and what they meant to us. I think both of us, Dirk and I, had some interesting thoughts on these. The first one, Henry Ford's A Universal Code, written by Bill Levinson. It appeared in Thursday's issue of Quality Digest Daily, and this is based on Ford's 1922 book, My Life and Work. And as a matter of fact, this book, Bill actually has annotated it and updated it, and it's now either out or will be out soon.
I believe it's out. I believe it's out.
I think so, but check out the story because you can find out more information about that.
If you Google My Life and My Work and then Levinson, the book will come up. But I do believe it's been released.
It's been released now. So the book, My Life and Work, the original, and I haven't read Bill's gloss on it, but I'm sure it kind of gets to this as well. It really gives voice to what Ford termed the universal code, and really it's more of a natural law. I think that Ford considered it to be a natural law. In other words, something that's kind of so self-apparent that it just is what it is, you know, and it's immutable to a certain extent. And it really encapsulated this idea of this universal code, really encapsulated what Ford had learned about business by that point in his life. And when he wrote the book, he was 59. And he had owned Ford Motor Company for about 2 decades, for about 20 years in the early 20s. So there really are 3 laws that he talks about here that really form the heart of his universal code. The first one is economic law. And basically what this means is that you can't get something for nothing. And it's pretty simple. I mean, you can't get something for nothing. At the extremes, really, where that boils down to is you neither can enact price controls, nor can you really speculate and have rampant speculation. Neither one of those really works because they're attempts to artificially depress or artificially enhance the basic value of something which is immutable, right? Essentially, in Ford's take, I think he's right. Workers cannot bargain for wealth that they don't produce, even if the unions bargain for them. And you know, Ford was not a pro-union guy, obviously. But what he's saying there is that there's value. There's inherent value, there's intrinsic value, and you can only do so much to enhance or depress that. Now, second law, however, kind of modifies that a little bit. This is scientific law, the second of these 3 laws. And the caveat there is that value can be enhanced and wealth can be created by producing whatever you're producing as efficiently as humanly possible, getting rid of as much waste as you can. And this was embodied probably most in the best possible way by Japanese manufacturing after World War II, where the Japanese, as we know, did not have a very strong base of natural resources. They still don't. They never have in that little island nation of theirs. But through being extremely efficient, they can use what they have to the best of their ability and they can make it worthwhile. They can create wealth through that kind of efficiency. The third of these laws, of these natural laws that he talks about within his universal code, is behavioral law. And really that comes down to the human element in this equation, which is that stakeholders who are treated fairly and profit accordingly are going to obviously be motivated to enhance value at every step along the way and eliminate waste if you make them bought in, if they're part of the solution. Ford's ambition, and he accomplished it really, and was maybe one of the first people to really accomplish this on a massive scale, was to compensate his workers well above the average and to see the value in doing that. Because he reasoned correctly that organizations that are bought into that level are going to, employees that are bought into that level, are going to want to increase value for the organization. They're going to want to get rid of waste because they're part of the solution. They're part of the profit here. And he talks about how you see the effect of somebody getting more in their pay envelope and how it affects the productivity of the company. Now to Ford and Levinson as well, this code is obvious. It's self-apparent. Again, it's a natural law to a certain extent. And I think really what it is it's making everybody part of the solution here. That's really the key part of it. I think the behavioral part of it to me is the most important, because you have to reach everyone in that way. And you can't leave it at your own doors. You can't just say, well, we're going to make our own organization as good as it can be, and we're not going to worry about, say, our suppliers. Now, Bill tells a story about, I believe the gentleman's name was Charles Sorensen. And Charles Sorensen was Ford's production chief. Well, they had a supplier who was charging them, apparently, $152 for a part, or some sort of a part or piece that went into the car. Now, they were making a profit on that, but through Sorensen going into that supplier's organization and looking at what they were doing, they were able to get their price down to $72. Charge Ford only $72 for it, and they made a heck of a lot more money. Right. They made more money at $72 than $152 because of the efficiency. And that's really what he's talking about here. And these lessons, this is a universal code. This is a natural law because the lessons haven't gone away. They're still with us today, and that's why Lean is so popular. That's why Toyota did such a great job, I think, in a certain sense, taking on the mantle of Ford, maybe in the 40s and 50s a little bit. And Ford now, of course, is doing great work with this as well.
Right, although he does point out there was a period of time after Ford where successors to Ford didn't stick to...
In the 40s there were some problems.
Didn't stick to Ford's rules and suffered the consequences of it. I mean, basically had to get back to basics after that.
But Toyota and other Japanese auto manufacturers did, and they studied Ford very closely. They studied what Ford did in the early part of the 20th century very, very closely, informing TPS, for instance. And again, now, as I say, Ford Motor Company today is really back in the saddle on this, and is really taking the lead on it again. So, interesting story. Again, that's Henry Ford's Universal Code, written by Bill Levinson. It appeared in yesterday's issue of QDD, and right down there for more information on the story.
That's right. Well, another interesting story this week, interesting to me anyway, because I could actually relate to it a little bit, was done by Matthew May. Learning comes first. Now, May talks about a lot of things in here, but we really focuses kind of on Taiichi Ohno's the Ohno Circle.
Yeah,
and
if
you're not familiar with the Ohno Circle, supposedly, a lot of people say this happened, Taiichi Ohno would take a group of managers out onto the production floor. He would draw a circle on the floor, have them stand in it for a day, and say, basically, you have to, standing here, I want you to observe everything around you and find what's wrong, essentially, with your processes.
Kind of like a Gemba stand.
Yes, instead of a Gemba walk, it's a Gemba stand.
Right.
And the idea being that by standing in one place and not being able to move, eventually you're going to start observing things. And one person who went through this process, there we go. One person who went through this process is, first of all, after standing there for a while, he began to understand what the process was, what was going on around him. Then he was able to start seeing problems. Once he understood the process, he could start spotting problems with the process. Once he spotted problems, he was able to start asking why. Why do these problems exist? Kind of the 5 whys example. Then from there, he could go on to root cause, and then from then on to countermeasures. And it's the idea that when you take yourself and you put yourself in a position where you're really forced to stay in one spot and look at things, you begin to become more aware of your surroundings. Now, there was another interesting example where this is taken in a slightly different direction by a police force. What this police force did is it takes its, I think it's new detectives, takes them to an art gallery and has them stare at a painting. What are they learning? Well, the longer you stare at a painting, any of you who have ever done this in an art gallery, particularly if you've gone on a docent-led tour, you start to notice things that you didn't notice at first. You start to go beyond, oh, isn't this a pretty picture by Renoir? And then you start looking, the longer you stare, you start looking at the characters, you start maybe to deduce some backstory on the characters. You look what's going on in the foreground, you look what's going on in the background, and pretty soon the intent of the artist really starts to come out at you. And that is kind of the point that May was making in here, is that whether it's an Ono circle or whether it's simply taking the time to really look at a process or a painting or anything else, you become more aware of what's going on in it. Now this enhances, this is good practice, I mean it enhances your observational skills, but also enhances your problem solving skills. You begin to realize that the whole really is made up of the parts, and if you can't see the parts, you don't really know what's going on with the whole, whether it's a process or a painting or anything else. So being able to take that time and really spend time observing something is really the goal of the Ono circle and the goal of what Matthew May was talking about in this article. You really have to learn to observe in order to move on to the next steps of process improvement.
And I know we have to move on, but you as a photographer have a personal experience with this as well that I thought was really interesting. You talked about it. I know we got to move on, but maybe you can quickly talk about that.
I'll just do it real quick. Yeah. Myself and a photographer in the UK would give each other photo assignments every now and then, just for the heck of it, and we'd post them online. But one of the assignments was find a spot. It had to be a fairly small spot, and stay in there for a day and submit 20 images, 20 photographs based on your location. So my spot was out in front of the courthouse in Nevada City. It's kind of an Art Deco looking courthouse, very, very pretty building. Well, so I went out there for the day, basically had a 60-foot linear foot area that I was standing in front of. So at first, of course, I'm taking buildings of the courthouse, I'm taking pictures of buildings across the street. And that was good for like the first 45 minutes or an hour. I still had 7 hours left. So pretty soon, you start looking, well, look, isn't that architectural elements interesting on the building? Look at the doorknobs, look at the handles, look at the light fixtures, right? And then maybe you look further down, what's beyond the building? How does this building contrast with the building next to it, which was a very modern building? How does the building across the street look when you look at it through the trees? What about the stuff at my feet? The longer I was there, the more I started seeing my environment, and my environment was more than I'm just standing in front of this pretty courthouse. My environment was everything that encompassed the courthouse and made the courthouse actually outstanding. If you took that same courthouse and put it somewhere else, it might not have the same effect. What gave that courthouse the beauty that exists there is not just the building. It's all the constituent parts that surround the building. And that's just something that comes out of observation that you don't get just walking by it and taking a quick picture of it.
And what's the word? The word is context. And that's what you're trying to do. And that's what Matthew May is talking about here. Put your operation, put your process into context by having the patience to really look at it.
Yep.
Really good article, really good article. Let's check that one out again. That's also right below the player page right down there. Okay, thanks, Dirk. Okay, well, going to turn now to our Tech Corner for this week. This is an interesting Tech Corner. Dirk and I have been chatting about this one. It's from InspectionXpert. And the product is InspectionXpert for PDF. The website right down there, as you can see, is InspectionXpert.com. And Dirk's going to run you through it right now. Take it away, Dirk.
All right, thanks, Mike. Okay, so probably any of you who had to do, let's say, first article inspection, know that the first thing you receive is probably a PDF of the print. Or some sort of image of the print. And this is probably the way it's going to look is, I have a screen share here. It's going to look something like this. If we can go to that screen share there in a second. Okay. You'll just wait for it. There we go. Okay, so you probably get a PDF that looks something like this. And you open up your inspection report, which is probably something like this. This is an Excel spreadsheet. This is a template for first article inspection for something based on, let's say, AS 9102. So what you're going to do is you're going to go to your PDF, you're going to take one of your characteristics, one of those dimensions, you're going to come over, you're going to type all that information into your Excel file, then you're going to go back to your PDF, you're going to grab the next characteristic, you're going to go back to your Excel file, so on and so forth until you have filled out your template that's just before you get started doing any kind of inspection. You've got to get this thing filled out. Well, if you've done this, you know that it takes a long time to go through all of these characteristics and transfer them over to an Excel spreadsheet. And this is a fairly simple document. So what if there was an easier way to get all of this data into an Excel format, into a spreadsheet? And that's what we're going to look at today. This is InspectionXpert for PDF from our friends at InspectionXpert. And I'm just going to start a new project here. First thing that comes up, and it asks me what kind of template I want. There's a number of templates available. You can even create your own template, but we're going to select an AS9102 template. I'm going to open up that very same PDF file that we were looking at. And you see what I have on my screen right now is we have the PDF on the right, and we have all the elements that we're going to fill in on the left. And I'm going to zoom in on this a little bit so that you can actually see what I'm talking about here. So give me 1 second. There we go. Okay, so all I'm going to do, I'm going to start taking dimensions from this drawing. And all I have to do is draw a box around it. The way this software works is optical character recognition. When I draw a box around that dimension, it puts a balloon next to it. And if you come over here to the left, you can see it understands that it is a linear dimension. It has read the value, it has read the tolerance, and created an upper-lower limit, all with character recognition. And I can simply go through and draw a box around all of my dimensions, and it's doing optical character recognition, or OCR, to grab all that. Now notice over here, this is a radius. This radius occurs 2 times. I can draw a box around that, and let's go back over to our details. You'll see that it recognizes that that's a radius. It recognizes that it has a quantity of 2. It has picked up the nominal value, 0.125, and it has created a default tolerance. Let's go back over here. Notice here that there was no tolerance specified on the print. What InspectionXpert for PDF allows you to do is create default tolerances if none are specified. So in this case, it's based on the number of decimal places in a radius. So because there were 3 decimal places, it said, okay, I'm going to give you a default tolerance of plus or minus 0.005. We can also do geometric tolerance. I'm just going to tell that that's what I'm taking. I draw a box around my geometric tolerance. We come back over here. I will specify that this was a profile of a surface. I will grab my value right there. And there, with a couple clicks, I've taken care of all that. And I'll just go through and just really quickly grab a couple of more dimensions. There's whoops, wait a minute. Specify that I'm doing a dimension, not a geometric. There we go. And we'll draw a box around that. Now notice this one, its tolerances are shown differently. Doesn't matter, the OCR still understands that this is a dimension with a tolerance. And here's yet another way of dimensioning a part. It also recognizes that. Now, at this point, I'm done. I can export this, but I want to point out a couple things. Here's my balloons. I don't like these balloons. I think they're small, they're hard to read, so I want to change them. So I am going to select all of my balloons. I'm going to increase the font size. I'm going to change the color. Let's make these dark brown. I'm going to change the inside of the circle. And also, I want them aligned to the left. There we go. So now this is much easier. It's much easier to see these balloons. I could also individually select these balloons and move them if they were covering up a feature, and I felt that was a distraction. Also, look down below. Every time I created a feature, it put an entry in the table down here, and that's actually what we're going to export. So now I'm ready to export this. I can export this as a PDF. If I do that, I get a PDF with the ballooned items overlaid on top of them. What I really want to show you is export to Excel, because that's really the purpose of this whole thing. Notice over here, I get a whole series of templates. Again, you could create your own template. I'm going to select the AS9102 and say export. And it is exported it, and let's open up our Excel file. Notice now, let me zoom back out. Sorry about that. Can I zoom back out? There we go. Notice now I've got an Excel spreadsheet that is completely filled in. This took me 4 minutes to go from my PDF document to filling out this Excel spreadsheet. How long do you think it would have taken you if you had to do that manually, not copying, but transcribing from your PDF or your image document into an Excel file? A lot longer than 4 minutes, and this was actually a very simple drawing. And now your inspection report is ready to go. All you have to do is start doing your measurements and filling in the meaty part of it. Okay, now another thing I want to point out, because this is really interesting, is suppose 3 months from now you get a 3 months from now you get a new revision. And you're not sure what the difference is between the old revision and the new revision. There's documentation that'll tell you, but you want to see it in an easily viewable way. I'm going to select the new revision and open that. What it's doing now is comparing the old revision and the new revision. And this will take just 1 second. And what I'm going to get is a document now that shows me, and I'm not sure how visible it is on your screen, in green it is showing me items that were added, and in red it's showing me any items that were changed or deleted. I could save this out as a PDF, print it, and have myself a little reference document showing me where the changes were. But more important, I'm going to now replace my document with the new one. Notice the ballooned items are still there, but of course some of these balloons won't make any sense because some of these items have changed or have been moved. So for instance, item 8 is no longer there, so I'll simply delete it and it will renumber the rest of the balloons. And also I want to change the location of this one balloon because this dimension has changed or has moved. So I'm going to move this balloon up here where it belongs. And there we go. And also I can continue dimensioning this document and getting the rest of the information. So for instance, there's an angle here, and I could select that angle. And notice if I go over here, it is recognized that this is an angle dimension, and it has the value, the nominal value, and it has the tolerance. And obviously I can also go back and change these balloons back to the type of balloon I want. So very quickly I have gone through and taken this document, gone from this document to an Excel file, all with just a few clicks. And much faster. According to InspectionXpert, they estimate that this saves about 80% of the time of doing a manual transcription. So for instance, this took me 4 minutes to take all that data and put it into an Excel spreadsheet. If I had done this manually, double checking to make sure that all my data was entered properly, this would probably taken me more on the order of 15 to 20 minutes. So a real savings on this if you're doing first article inspection. So again, this is InspectionXpert for PDF from our friends at InspectionXpert. And if you want more information on it, there is a link below the player page.
Hey Dirk, before I let you go off the set there, we actually have a question from a reader, I believe,
cool.
who wants to know more about this, I believe. So, so guys, can we show that? I don't know if you can read that, Dirk.
Okay, the question is, how does this software interface with the more and more common digital solid models? I'll get back to, I'll have an expert from InspectionXpert get back to you. This works, from my understanding, this works with 2D drawings. This is specifically for getting this data from a 2D drawing, which if you're going to be machining a part, you're not going to be machining from a 3D model. You're going to be getting a document, something like this. You're going to be getting, in most cases, I believe, a 2D document that you're going to set up your measurement routines from, I believe, but I'm not positive on that, so I'll be sure I'll get somebody from InspectionXpert to get back to you on that. I believe we probably have your email on that, so I'll be sure to get back to you on that.
Great. All right. Well, thanks, Dirk. Yes, there it is, InspectionXpert, and the product name, of course, InspectionXpert for PDF. The website, as you can see right down there, is InspectionXpert.com. Really good tech corner. Thank you to InspectionXpert for providing that to us. Thank you, Dirk, for running us through that. That interesting tech corner today.
That was fast.
That
software actually does quite a bit more. Yeah. But the main idea behind it is optical character recognition, which if all you've received, and very often, that's the reason this was made, is very often what a shop is going to receive is a print.
Yep.
And you can't do anything with the print. It's
Right.
just an image. And so somehow you got to get that data onto your spreadsheet.
Good.
Yep.
Thanks. Okay. Well, before we go, I want to talk about something we got coming up at the end of the month. The next episode of Gauging Quality is going to happen on May 23rd, Thursday, May 23rd, at our normal time, 11 a.m. Pacific, 2 p.m. Eastern, right down there. It's about the care and feeding of your hand gauges, making adjustments to your tools, your equipment.
Yeah, there's
basically
certain
that kind of thing.
Yeah, there's certain things. Craig Howell is going to show us the things that you can do with your gauges that you don't necessarily have to send out to a calibration lab. There's certain things that you can do yourself, and of course there's certain ways you need to take care of your gauges, and that is a lot of what we're going to be covering on the show, plus more.
Yeah, so that's May 23rd, Thursday at, again, 2 p.m. Eastern, 11 a.m. Pacific time, so tune in for that one coming up soon. And also next Friday we have Mike Micklewright.
Yes. Hey, that's me.
That's right.
Yes, we have Mike Micklewright in person, or
Mike's going to be here in person. Yeah,
okay.
Mike's joining us in Chico, and we're going to talk about a lot of stuff, but primarily his article on being a not a ruthless but a relentless sorter.
A relentless sorter.
Yeah,
that's right.
Good stuff on that. So
live on the show.
Check that out. That's next Friday.
And if you got any questions for Mike Micklewright, the wise guy, queue him up and get him to us.
QDL@qualitydigest.com. All right. Well, that's our show for today. Thank you all for joining us. Definitely big thanks to Darren Otten and Luke Hendricks of CSU Chico and the Sustainable Manufacturing Program for joining us on the show and giving us an up-close and personal look at their project. Go Wildcats. Good stuff there. Thank you to Bill Levinson and to Matthew May for great articles. Thank you to Karen Martin for a great book.
Yep.
And, of course, to InspectionXpert for a really interesting tech corner. So that's it. That's our show. Have a great weekend, and we'll see you next week.
So long.
Bye.
Thank you.